this stuff yet. Back in 13.1, you guys were finding that all the trig functions given certain values. For example, we had a problem where if I gave you the secant of theta was 5/3, you guys are able to build the right triangle, give me all the other 5 trig functions without too much of a hassle, correct? Yeah. Well, what we were doing is just saying, here's a right triangle, this is what was going on. Instead of doing it in just that singular sense, one-dimensional, we're going to put it in 2 dimensions by putting it on a graph, which means you get positive and negative x values depending upon where ordered pairs are placed. So let's look at a real easy example of placing an ordered pair on a grid, and we're going to list out all 6 trig functions that has a terminal side of theta that goes through that point. It's a lot of words for something that you'll see is really easy to look at. Okay.
Do we need sides of a triangle for a trig?
Well, yeah. And it's so funny that you ask, because I bet you'll find out that we get sides of a triangle here. That's crazy. I know, I'm trying not to get too much of a spoiler alert here.
Hold your horses, guys.
Yeah, hold your horses and your cows. Remember, I think I told everybody, I almost ran over a cow this morning. There was a cow loose running down the road. I'm not lying, I had pictures of it. I'll show you the pictures. I'm driving into work this morning, 6:30, and I'm looking ahead of me like, that's a cow. Right in front here.
There was a vulture in one of the, there was like a vulture thing in one of the foreign languages.
Because no one remember last year in geometry when a bird flew and hit the It like flew dead into the window next to me and then dropped to the ground and everyone looked over and was like, and there was just a dead bird laying right there.
So you have this aura of just dead animals.
What?
Nice. All right. What quadrant does this go into?
4.
4. Okay, so here's what happens. What happens here is you have this, remember this is always your initial side, and as you come around, you wind up with some value here where 2/3 lies on the terminal side of the angle. And you get this ordered pair here at 2 and -3. You okay on that? What you're able to do with this then is you're able to figure out you're able to figure out that you get this value by coming back up and over, and you create a right triangle. Now, what we're looking at here is our theta value is coming all the way around, but isn't its reference angle on the inside of that triangle because it's the 4th quadrant? Because it's bounced up to the x-axis. So we still call this theta. So our theta on the interior of that triangle, we're able to list out trig functions. But what do you have to know?
The angle.
We have side lengths. We can get side lengths. That's easy because our side lengths are at 2 and -3. It's negative because it's a direction. It just happens to be going downward into the 4th quadrant. That's why it's a negative value. What value don't you have? How do you get it?
A squared plus B squared equals C squared.
Okay. So in this case, it's Pythagorean theorem. So your book in this section calls it R. Because as we get into this more and more, we're actually dealing with the radius of our unit circle. So this value of R is going to be our radius. So R squared is x squared plus y squared. So in this case, we're going to get R will be the square root of 2 squared plus -3 quantity squared, and you get the square root of 13. Good. So now think about it in terms of x's and y's. If this is my x value, This is my y value, and this is my r value at root 13. Sine, cosine, and tangent. We'll do the inverses in a second. The sine of theta is opposite over hypotenuse, correct? Y over r.
Can you explain this to me?
What's, in this case, it's negative 3 over root 13. We should all be able to rationalize that without a hassle, correct? Multiply top and bottom by root 13, you get negative 3 root 13 over 13, good. Cosine of theta. Well, cosine is adjacent over hypotenuse. It's x over r, very good. Which is 2 over root 13. Yes, ma'am.
So will it always be like sine is y over r and cosine is x over r, or like can it switch sometimes? Like does like okay.
It's always this.
It's always y over r and x over r.
Yeah. Tangent of theta. Oops. Tangent of theta is what over what?
X over y.
Look again.
Y
over x.
But that can switch though, right?
Which is what?
The tangent can switch because of the theta.
No. Because when you're at theta, won't your opposite always be a vertical?
Oh,
No matter where your theta is placed, your opposite, because you're looking at a reference angle. Your reference angle being bounced down, if I'm here, I'm looking at a vertical. If I'm up here, I'm looking at a vertical. I'm always looking at a vertical. A vertical is always my opposite. It's crazy how this math stuff works. And you wind up with negative 3 over 2. So we're okay on that?
Yeah.
Yes, ma'am. What I'm doing here is, when you multiply the top and bottom by, if this, the root 13 is here, I'm multiplying the top and the bottom by the square root of 13, because remember, this is just a value of 1. Root 13 divided by root 13 is 1. All I'm doing is changing the shape of it without changing the value of it. It's proper, what's it, negative 3? It's proper to multiply these together. So the square root of junk times the square root of junk is junk. That's all it is. Because this, in essence, is the square root of 169, which is 13. And the numerator just stays the same with slapping the root 13 up top. It's a, I shortcut it because we did it a long time ago. Okay, that's all. Little practice, I'm sure it'll come back. If it doesn't, just swing it and I'll show you the trick. Do the inverses. The inverses of all these then, you have cosecant, secant, and cotangent. Well, cosecant is hypotenuse over opposite, or in this case, r over y. Which is, now here's the reason why I list the first one before I rationalize. Because now I have my opposite over hypotenuse. All I have to do is just take this value, flip it. And I'm done. Do I have to put the negative in the denominator? Can I float it anywhere? Anywhere, as long as it's there, you'll be all right. Same thing with the secant. The secant is the inverse of cosine. If cosine is x over r, secant is? And we had, what was it, 2?
No, it's
Oh, sorry.
13 over 2.
Thank you. And then lastly, the cotangent is the reciprocal of tangent.
Y over x. X over y.
You get negative 2/3. And like you guys were asking, remember when you place theta, theta's reference angle will always look at a vertical. So your opposite is always going to be your y value, no matter what. Yes, sir.
So if you were to make the points, like, because we learned about how you can switch the signs, the numbers, so if you can make it 2 and 3, you would have the exact same numbers, you make like a full circle around the
Mhm.
triangles.
Yes. That's exactly what happens, because if you mirror this to have the same reference angle up here, this value would be at 2 and 3. If I mirrored over here to the same reference angle, this value would be at -2 and 3. When I come back down here with the same reference angle, this value would be at -2, -3, because they match themselves through. Because this radius stays the same, and you make a circle.
That's actually
So the beta would go back to the vertical side.
Yes.
Okay, the number.
That's exactly what happens, Clay. That's exactly how this is how all this thing comes together. I know, it's crazy. It's connect the dots.
Not even gonna have my joke today.
Oh, come on.
Not even gonna
A
have my
Pee Wee Herman reference, you can't even laugh at that?
I'm being nice, so everyone else has to be mean.
Not scary, is
It's
it?
American hero.
So let's talk about something a little bit different.
Oh, shut up.
Quadrantal angles.
Right for
It's like quadranta.
Argos.
Have a depth in your fan and see how well your brain is. Yeah, I went there.
Mr. Rick has no shame.
Uh-huh. And you know what? My brother-in-law would laugh at that joke, too. It's uncomfortable, isn't it? He would do that. So it's okay. This is all processes of mourning.
High five.
No,
What's the
I'm
other?
sorry. It was.
Do you need a moment?
You guys, it's okay. Death happens. Death sucks. Death is awful. The crap that I've had to put up with, had to go through, I don't want on any of you guys. Seriously. If you have to take a second and just make a bad joke, I don't mean to make it at the expense of you. I've gone all day and I've done pretty damn well. I'm pretty all right. So I'm sorry. It's okay. It's like the cow joke. I'm not lying. It was just made the day awesome. I came to work not knowing if I really wanted to be here yet. And there was a cow
And that
running
cow
down
tells
the
you, yes, you do.
Yes, and if I had my truck, I would have taken the cow home to my freezer. But my wife had my truck today. And it was cold.
Yeah, well, my car's I hit a deer.
Don't. A deer?
That was a good one.
Was it a female deer?
Yeah. That's what I wanted to I'm 38.
You're evolving.
You jumped out in front of me.
I'm sorry.
I'm really glad.
You guys been mortified. You guys are all like, Daddy said no. There's really not a lot of stuff off limits after a while. Alright, anyway. Quadrantal angles. Quadrantal angles are just the angles that land on the your axes. The quadrantal angles are the angles that land on the axis. 9 doesn't land on the axis.
No, I was telling the story about how I killed her.
Okay.
How cool.
Your quadrantals are at 0, pi over 2, pi, and 3 pi over 2. Okay? What's happening here is we're going to start to take that radius value, and we're going to call that radius value 1. Because in a circle, the radius doesn't change. Do you agree? What changes when you place it in 2 dimensions is the fact that your ordered pairs move. So at 0, what's your ordered pair at that point?
1, 0.
1, 0, good. At pi over 2, what's your ordered pair? 0 and 1.
Where did the one go?
It's the radius. I'm just giving a circle a real easy radius of 1. Okay.
So
Our
it's
unit,
just like,
yeah, our unit circles all have to have a radius. It's going to have a radius of 1.
okay.
I'm sorry if I forgot that.
That's okay, I just like, I heard if you were gonna make it 1, but then I didn't really collect what
That's
I
okay.
did.
So the next one is negative 1, 0?
Correct. The next one is at negative 1 and 0 at pi. And then the last one at 3 pi over 2 would be at 0 and negative 1. So what happens here as we start to go through these, you're going to be able to start to figure out what your trig functions are going to be in relation to your x's and y's again. Because my x value at 0 is 1, my y value is 0, my radius is 1. So if I want to go through lists, sines and cosines here, if I want to do the sine, let's do pi over 2. Sine of pi over 2 was y over r. What's your y value? And what's your r value? Sine, remember, sine is y over r. If I'm at that, what's y and what's r? 1 and 1. Ordered pairs, man. Ordered pair. No. No. I'm at pi over 2. What's pi over 2?
Oh, yeah.
Okay.
Don't use that.
I'm 1 over 1. So that means the sine value of 90 degrees is 1. Huh?
Why is R? This change has to why is R 1?
Because I gave it a 1. I'm just making it easy.
Oh, the radius is 1. Okay.
If I'm at 90 in a right triangle, what's my opposite? Not my mom. It's not my mom. Nicely done. Yeah. Anyway, what's opposite my 90 again? It's the hypotenuse. So what's the hypotenuse divided by hypotenuse? 1. No matter what your hypotenuse is, here I'm at a 30, 60, 90, it's 2. What's 2 over 2?
1.
What's the sine of 90? 1. It's always going to be 1. All right? You go through the rest of it. What's the cosine?
Not 1. Almost.
Cosine is x over r.
Almost.
0 over 1.
Wait.
Tangent is y over x. What's y value at pi over 2?
Keep dividing by 0.
You can't divide by 0, so what do you write?
Error.
You don't write error, you write undefined.
Just right here.
Error. Yeah, I calculated says error, domain error.
So we have 1. That doesn't make any sense. How do you have a circle that has an undefined side?
It doesn't have an undefined side. It says
Circle.
It's not talking about the circle. I'm not looking at the circle. I'm looking at the pi over 2 value. At pi over 2, there's no tangent. It's undefined. Now, all your inverses.
I just gave up.
Your cosecant. What's the inverse of cosecant? Well, it's the inverse of sine. So what would the cosecant at pi over 2 be?
Will be 1.
So it'll be 1. What's the inverse of 1 over 0, or 0 over 1? 1 over 0 should be undefined. So the secant would be undefined. Remember when you did slopes? If you had a 0 slope, it was a horizontal line. If you had, what was reciprocal, or the opposite, or the reciprocal of a horizontal line was vertical. What's the slope of a vertical? Undefined. Undefined and 0 are reciprocals of one another because of horizontal and vertical. It's the same basic idea. So the reciprocal of that would be at cotangent, would be at 0. The reciprocal of undefined is 0. The reciprocal of 0 is undefined.
Wait, so it's going to
That's so weird.
Yeah. Because what you're doing is you're flipping each of these fractions.
Is this going to be like a every time thing?
Yeah. If you have a reference angle at pi over 2, these things occur.
Alright.
And it works out to be extraordinarily simple as you start to build more and more into this because dun dun dun.
Really? This is what I wrote on my
Your ordered pairs become cosine sine for everything. Everything, all these ordered pairs in our unit circle are defined by cosine sine. Let me show you how this works.
Is it because each will work out to be like a whole number?
Not necessarily a whole number.
Oh, sweet circle.
Yes. How do we solve it? Well, we first have to learn what we're doing first. We're not even at the solving part yet.
Oh.
We got ways to go.
I told her to get a new book.
No, we're running a little late. Too many dead brother jokes. So here's what I want to start with here. What I want to start with is a very simple idea as far as why our ordered pairs work the way they do. What happens in our unit circle? We wind up with basically two different sets of angles. 30s, 60s, and 45s. And that's 3 sets, sorry. You can throw a 90 in there for the quadrantals. So anyway, you basically are working with these two angles, or these two triangles all the time. What I'd like you to do is just on that sheet, just put these two at the bottom so you can have a reference point of where this is coming from. And we know that at 30 degrees from the other day, we knew that to be in terms of radians, pi over 6. Vaguely remember that? I know you guys are looking at that. Which means that in the second quadrant, if it had a reference angle of 30 degrees coming up, this was at 150. And when we did the reference angles in terms of radians, we came up off of pi, we came up a sixth, so it was at 5 pi over 6, yeah. We came down off 180, 30 degrees, so we were at 210. We added 1/6 to a pi, we had 7 pi over 6. And then lastly, when we came over to the fourth quadrant, when we came down 30 degrees, it was at 330. And we also called that what in terms of pi? Remember that one? 1 less than 2 pi. 11 pi. I'm sorry, what was that?
11.
Yeah, 11 pi over 6. I thought somebody had a question. Okay. So we had 0, 2 pi, pi, and we'll build in the rest here. So what we do here is we know that our ordered pairs are going to go, well now you do, cosine and sine, just for shortcutting it. What's the cosine of 30 degrees? Well, cosine of 30 degrees is what over what? It's adjacent over hypotenuse. So what's the cosine of 30? Okay. What's the sine of 30?
It's an ordered pair, isn't it?
So isn't this my x and my y value? So what happens here is that if I move this horizontally to have the same reference angle, what changed? The x or the y? The x, the cosine. The sine stays the same because we talked about why that happens because of the reference angles. Yes, the one with the G, the sign with the G, yeah. So you
Is
get,
it then the 45-degree angle for the cosine? Oh, wait, no, for the cosine.
no, I'm not on those yet, I'm still working on 30s, my friend. What changed there is that I just went horizontally across, and my X value changed. Now if I go vertical, what's gonna change when I go down to 7 pi over 6? Y value becomes, does the X value change? No. And then when I go back horizontal here, it is the same as the vertical X, but the Y value changes again. You don't really need it in geometry for anything. You really don't. So what's happening here is that each one of those 4 points lies on the circle itself. Notice how they all have the same radius. The radius doesn't change there. You can draw in all of your little right triangles. All those have the exact same theta-based right triangle of 30, 60, 90 that you're just building off of the ordered pairs in relationship to theta. Now if I go up to the 45, if I go up to 45 here, this is now what? Pi over 4?
What? Is it 4? Oh, wait, never mind. Okay.
What's half of pi over
Yeah.
2?
Okay, I got
Or
okay.
45 was half of pi over 2, so it's half of 90?
Yeah. I was actually talking about the different, like, the ordered pairs for a second.
Oh, I got you. In this case, what's the cosine of 45? 1 over root 2, but we write it as? Good. And what's the sine? Same thing, isn't it? What I want you guys to do is to fill in the rest. You're going to use that information that we've talked about here today as far as how things are mirrored via the reference angle. Look at the different signs, SIGN. Look at the different signs, the SIGNS, as you're going around for your positives and your negatives. Because now, as you start to learn more, dependent upon your theta value, which quadrant it lies within, will tell you the sign, SIGN, of the trig function. Whether it's plus, 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 minus, plus, minus, minus, and so on. Yes, sir?
Does that mean the extra line is everything about 60 degrees? That third line that we didn't address, is that all 60 degrees
Yeah.
stuff?
Yep. Yeah. Thanks, Mike. The next one is your 60-degree angle, your pi over 3. Okay? I want you to work on that over the weekend. It seems daunting to start the idea, but everything is building itself off of something you're good at. 30, 60, 90, 45, 45, 90. It's a matter of walking yourself through and setting it up. We'll get into more of this then Monday. Okay? Yay.
Wait, that's